going to work. Oh, YouTube's working. And Twitch. Holy cow, it's working. That only took forever. Get it all set up and ready to roll here. Hi, bud. How's it looking? Wonder what the delay's like as well. Seems to be okay. Oh, how's it look, bud? All right. Awesome. Okay. So looking at your assignment here, you got a bit about just understanding sine and cosine for graphing purposes, basically. Understanding the amplitude, uh, the period, shifts, all that stuff. So, how do you find your understanding of the shifts and like the amplitude and all that stuff? How do you find you are with that? Okay, so you know how to do n? Well, let's see what you got. Define for me the first one. Y equals 5 cosine 2x plus 7. Yep, amplitude A is 5. Keep going. Yep. The period, because you used degrees, is 360 divided by b, which is 2, so you get 180 as your period. And you get a vertical shift up. I would say a shift up or down. Okay, so what do you need to do? You need to graph this function. So this should actually be pretty easy for you. Where does cosine start? Cosine of 0 is what? Well, what's cosine of 0? Not anything to do with the actual, not our function or anything. Just what's cosine of 0? You can even look on your... Yeah, 1. So the regular graph, if I just make this like a 1 here, cosine of 1 goes down like this. This is a regular cosine. Okay? From 1 to -1. In order for us to do all the shifts, we have to just kind of like do it piece by piece, if you... So I would draw the regular cosine, then I would do like maybe the amplitude change, so 5 to -5. And then I would do the period change, so from 360 drop down to 180, etc. You don't know how to graph it properly? Okay. Well, let's start by graphing a regular cosine. Cosine starts at 1, goes to -1. Yeah, no, that's all you really need. And from 0 to 2 pi, or 360 degrees, I say for you. Kind of a regular sketch. This is cosine from 0 to 360. Goes from 1 to -1, and that's all it is. If we went further to like 720 degrees, then it would become periodic. It would do it again, right? So if we went further, it would go down. Same thing. Okay? But we only need to go between 0 and 360, so this is what we're going to do. So this is y equals cos x. Okay, our base function. If we want to start incorporating all the shifts and stuff to it, we need to maybe do it one step at a time. So which one do you want to start with? Oh, thanks for the follow, bud. Which one do you want to start with, CW? You want to start with changing the amplitude, changing the period, or doing the shift? Amplitude. Okay. That one should be pretty easy for us to do then. So the amplitude, as you already know, has this 5. So everything on it is already multiplied by 5. So where it was a 1, it's now 5. Where it was -1, it's now -5, right? So if we draw the graph again, I'm just going to keep it the same size, but I'm going to change the numbers around. Okay. Here's y, here's x. So instead of 1 to -1, we now have 5 to -5. If you had a graph piece of paper, you would do it much bigger, right? But everything else still stays the same. So this is 360 degrees. Here's still 180 from -5 to 5. Okay, so there's y equals 5 cos x. Well, this is all it is. You should be writing this down as we go. Like, I'm showing you how to do it properly. So you should be writing this down. Yes, but we're getting there. I'm showing you step by step how to get there. I know you're going to have all your notes where it's all combined into one thing, but if you don't know how to get there, you're not going to be able to do the last graph. I'm showing you step by step how to go from the base graph, which we all know, to being able to draw with all the chunk functions and shifts and all. So this was like the first one was drawing the base. The next one, when we added the amplitude. So now we have two more things we can choose from. Let's change the period next. So you know that the period is now 180 degrees. Okay? So let's start drawing that again. But now we've got our 5 and -5. We're going to keep that the same. We're going to stay that together. So here's our 5 and our -5. Here's our 360 degrees. Here's 180. Okay. If we incorporate the period change, so now the whole period is 180 degrees. Okay. Not 360 anymore. Which means if we still start at 5, we're going to end at 180 and end at 360. So there's going to be 2 of them this time. Down like this. Up. This. No. You see how that changes? If you wanted to like test it, yeah. But you can also remember, so this was like a simple one where it just changed evenly to from 360 to 180, but what if it doesn't change? It's like a weird period change. What was it, 2x? So, for example, we know I know Mio. No, it's still a cosine function. We're just incorporating a larger interval. So this is still a trig function. It hasn't changed. There's the polynomial functions, where we have like x to the 4th plus x cubed, etc. Polynomials. But this is still just a regular trig function. Another way we can think about this is we know that cosine of 90 degrees what do I want to say for this? Cosine of 90 degrees is 0, right? Okay. So we know that the value of cosine is 0, right? But we have 2 times x, okay? Which is inside the parentheses. So that means our angle is 2x is 90 degrees, which means and when x is 45 degrees, this is 0. So right here is 45 degrees. This here would be 90 degrees. And this would be, what, 135? You see how that changes slightly? You can do little tests to understand and just reevaluate where a function has its value. Okay? So we're not done yet. We still have one last piece. And that is our shift up 7. So, remember here, this is the y equals 5 cos of 2x. All we need to do now is move everything up 7, right? So where it was minus 5 plus 7 would be 2. 5 plus 7 would be 12. So our shifted graph would change from 2 to 12. 1, 2, and then everything else stays the same. So I'm going to write 180 degrees, 60, here, here. Little guides for myself drawing. So you see how we went from the original graph and adding each piece of the shift and all that to get to our final one. I know my sketching is pretty terrible. Okay. So did you see how that worked though? Do you feel confident that you can understand how to go from a basic graph and incorporating each piece to get to your final one? Very good. So what about B part, the sine one? Tell me about that one. I'll do that. So B, we have negative 0.5 sine x minus 30 degrees minus 4. Actually, amplitude and the minus sign are slightly different factors. So the amplitude would be the 0.5. The minus sign comes after that. Well, this actually tells you it's not left or right. It tells you right there. This minus sign tells you which direction. If this was x plus 30, it would be one direction. Since it's x minus, it's another. Again, they tell you it's not, there's no or, so I need you to figure it out. Tell me, is it up or down, or left or right? You have to choose them. So at this, the shift down is right. However, it's not a left shift, it's a right shift. Actually, you can even check on here. When I gave you these, this has all the shifts in it right there. So if we have f of x minus some constant, which is like this is shifting right. Okay. For example, sine of 0 is 0, right? But if we have something like 0 minus 30, that's not 0 anymore. That's 30 degrees. So we need to actually move over to the right so that it's sine of 30 minus 30 to give you 0. See what I mean? So if it's a minus sign on the inside, it's shifting to the right. If it's a plus on the inside, it's shifting to the left. Easy peasy? Okay. Now the last thing is this minus sign in front. The minus sign in front means you're kind of swapping, right? So for example, if you had 1 originally, when you multiply by a minus, you'll have minus 1. It's a reflection. Or on our sheet here, when you have y equals the minus f of x, so like minus of sine, this is a reflect about the x-axis. Okay? So if we had some value that was like here, and then we multiplied by a minus, it would be down here. See how that changes? Okay. So now we have all the information we need to draw the graph. So let's start with the basic sine graph. From here, sine Let's start here. Here's our y, here's our x. Where does sine start? Sine of 0 is 0, remember? 0. And then it goes up to 1. It goes down to 1. And then it finishes off back at 0. 360 degrees. Okay? There's 180. Try this really well. Here. There we go. So there's our basic sine graph. Y equals sine. Now, how do we draw with all the changes on it? Which one do you want to start with first? Okay, amplitude. Amplitude is 0.5, or I like to say 1/2. So it's like dividing by 2, so wherever something was 1, now it's 1/2, right? So where it was 1, it's now 1/2. Make sense? Everything else stays the same. Oh, there's 180. There's 360. Start at 0, go up, down. Oops. There. Come on, Brian, let's get a little smoother line here. Close enough. Okay, so there's y equals 1/2 of sine x. What do you want to do next? The shift, let's say horizontal. I always like to do the vertical one last since it's the easiest. Cool. So we're moving to the right 30 degrees. Okay, I can wait. Okay. Start writing. Okay, bud, you go eat. How long will you be? 15, 20 minutes or so? $30. Okay. You're going to be away. I'm going to quickly take a look Sounds like my dinner will be soon. I will be right back. Okay, let's see what else can work on. Well, use a way. Could make my derivative page while we're waiting. Unless anybody else has any questions. No questions? Okay. Let's open it up. Where are you? Well, if they're so lovely. Let's clean this sucker up. Let's see. This is just going to be a straight derivative. Yep. A little bit of tweaks. How did I draw these bigger? steal our logarithm record. Good. I will do that after. Okay. I think maybe I should steal that other one too. Cool. All right. One is started. It'll be blue again. Let's see. What do I want? Do d by dx. Okay. Actually, take the look too much. Bit less better. Very nice. Okay, first one will be constant. Some constant C. Oh, derivative of a constant. You can fit quite a few of these with this size. See how far we go with 3. C times of x equals C times. Do I want to do d by dx or do I want to do prime? I think prime. Slightly nicer and right. Makes it easy. The only thing is where is it? Nope. Nope. Not bad. Hmm. Some. X. You do plus or minus. Wonder if there's a plus or minus. There is. Nice. G of x equals f. We'll move it over. Plus or minus. You're back this fast? Okay, well, you let me know when. I'll just keep working on this. I have to always kind of check and see the size of it. Closer. Yeah. Product rule, quotient rule, mean rule, and then I won't. Okay, this will look okay. Product rule. Down a bit. Product rule of f of x. L1 is x. Okay, bud. Just quickly save the. Okay. Back to what we were doing. So we were at this point where we had y equals 1/2 of sine x. Then we were going to do the horizontal shift, which was shift right 30 degrees. So when we're shifting right 30 degrees, remember we're moving everything to the right by 30 degrees. So for example, you see that here at 180 degrees, it's at 0. Well, if we add 30 degrees, it'll be 0 at 210 now, right? This is 0 at 0. We add 30, now going to be 30 degrees when it's. So here's 30 degrees. And here, what's another one we're going to do? This was 90, so we'll do 120. $80 will be 210. And in between, that'll be 300. And this is 330. 360, we aren't going that far. We're only going up because our question says for x between 0 and 360 degrees. So here's our 1/2, our negative 1/2. Actually, I'll just write them up. Okay. So far, so good. Do you know how I got these values? So we moved everything over by 30 degrees. So it starts here and it's going to go 30 degrees. Before 90 degrees was the top. Now it's 120. So here to here. And then 210 is now midpoint. 300 will be the bottom. And 330 is not quite. How do I want to put this? It's kind of in the middle. So it's kind of supposed to be. Goodness, it's completely awful. Okay. 90 goes to 120. Yeah, that's good. There's 270 here. If I draw 360, this is supposed to be midway. The line is a bit off. This is 360. We only go to 330. We only go to about here. And no, how do I want to draw it? It would have been smarter if I used graph paper. And 300. So this is 390. 60 here. So it would go to 390, but we're not going all the way to 390. We're stopping at 360, so it'll be there. That's better. Okay, and then this continues down approximately like that. Not actually 1/4, but pretty close. So do you see how the shift changed? Cool. So that was y equals 0.5 sine of x minus 30 degrees. Okay, now let's incorporate that minus sign, right? This minus sign in over here. So now we have to reflect it. We're going to draw the same thing again. But now everything that was on the bottom is on the top, and everything that was on the top is on the bottom, because that's what happens when you multiply by -1. 1/2 becomes -1/2, right? So this still stays the same at 1/2 and -1. And I'm going to try and make this as close as possible to 30 degrees, 120, 210, 300, 360. So now we're multiplying by a minus, so flip over the x-axis. So it was going up, now it's going down. And 20 becomes minus. 210 stays the same. And 300 back up to 1/2. And then somewhere over here. Do you see how the negative worked out? And now, the last piece, you obviously know, shift down by 4. So, everything has to just go down by 4 units. So, whatever was 1/2 minus 4 turns to what? Four is the same as 8/2. So 1/2 minus 8/2 is 7/2, and this is minus 9/2. Yep. Perfect. So, just try your thing again. And draw a little down. Here's our axes from before. 30, 20, 210, 300, 60. And now we go from minus 7/2, which is minus 3.5. So we'll say that's here. And we'll say this is minus 9/2, so minus 4.5. And then you just redraw your graph. 30 degrees would be its 0. The 1, 2, 2. Here. There you go. Minus 4, right? So do you see how all of those add together? Do you think you could like recreate one? Okay, easy. Then the second question you could do super fast and easy. Because all of it, like 1 through 9 in the second question, are just like, what's the amplitude? What's the period? What's the amplitude? What's the period? Three. So 3 is this this graph one. And here we are. 3. Do it this way. A little easier. 3. Load on a trailer has been shifted, causing the rear end of the trailer to swing left and right. The distance from one of the taillights on the other trail to the other curb varies sinusoidally with time. So, sine. The graph models this behavior. What is the equation of the axis of the function, and what does it represent in this equation? I don't know what Bitcoin will be in a year. I'm going to assume Bitcoin will be just as crazy as it's always been. So, FTW, what is the equation of the axis? Basically, like, what's the center? Bitcoin's gonna do bad. Keep Bitcoin dropped so hard. Cryptocurrency is too risky. So I'd look closer at this one and be like, the highest peak is 2, the lowest peak is 1, and the axis is the center between the two peaks. So what is the center between 2 and 1? Not 0.5. 0.5 would be down here. Yeah, 1.5. Because the axis is basically the center of the amplitude. It goes from 2 to 1, so 1.5. So think of it this way. You still have to write y equals 1.5. What is the amplitude of this equation? So in the B part, what is the amplitude? Yeah, I know. We're answering. You can write it down. We're just looking at this for now. You have the equation. So A is y equals 1.5. Yeah, I do this on stream all the time. This is the first time I got it to work on both the restream, so YouTube and Twitch. Usually my internet connection's pretty terrible, so trying to get it to work. Amplitude is not 1.5. Remember, the amplitude is like the distance from the axis to the highest point, and the distance to the lowest point. So if the center no from the center is 1, so 1.5 is the center. The height is 2, and the lowest point is 1. So what's the distance between 1.5 and 2? Seriously? You're joking. That's not true. Thousand bits? Thank you. I've never seen it. I haven't seen it. Oh. No, so what's the distance between 1.5 and 2, FTW? Here. Amazing. You should take a look and see what I've been making on my Instagram. It's pretty hilarious. FCW, what's the distance between 1.5 and 2? Because we've got, oh, here, I should draw this differently. Okay, draw on here. No, it's not 1.75. 2. Think of it this way. You're here at 1.5. And you go up to 2. How high did you go up? Yeah, 0.5. So the distance between 1.5 and 2 is 0.5. The distance between 1 and 1.5 is 0.5. So your amplitude is 0.5. You see how that works? Okay. Now, the C part. What is the period of the function? So remember, what does period mean? Well, we don't have time in seconds is not in degrees. Remember, see our time, our bottom axis, it goes 1, 2, 3, 4. It's not 360. We have to change what the period is based on what our axis is. So, no, this is high school. I think this is grade 11. You should see, oh, you got people asking me from like, where is this guy from? Kashmir? I don't know where that is, but I have a bunch of stuff for this guy too. Little baby math? Ugh. You know, having a degree in math does not mean you can add or subtract, just to let you know. Yeah. His grade 12 wants me to do a whole bunch of inverse trig functions, which we don't even bother with for most of the time here. Kind of funny. Differences in different parts of the world. Anyways, the period of the function. Remember that period of the function for sine remember sine started at 0, went up and down and then back, right? This was 360 degrees, right? Okay. So if you look at the graph of sine, it goes from here to the top to the bottom and back to 0. So it did one full cycle. One full cycle. Let's compare one full cycle to our question. One full cycle would be from like this point at 0 So it goes up, past, and then back up again. One full cycle would be how far? Well, 1.5 would give you here. That's not one full cycle. Remember, you got to go back to the 0 point. Yeah, so the full period, or one period, would be between 0 and 2. So for our question, the period is between 0, what do they use, x? Or t? Well, what's chapter 6? But chapter 6 must not be much of anything. And just bring it up. Let's take a look. Oh, chapter 5 is what we did. Oh, the ratios. Well, that's easier. 5 and 6 kind of go together. Okay. What's next? Bonus marks for drawing pictures? Maybe. So we need to determine the equation. Okay, for the D part. We know the amplitude is 0.5. There's no horizontal. There's no horizontal shift, but there's a vertical shift. So I want you to tell me what the vertical shift is. No, it's not 0. 0's down here. No, don't guess. I want you to take a look and see. Remember that sine starts at 0. Okay? Sine of 0 is 0. This is a sine function. Sine starts at 0. So if we are up to 1.5, how far did we go up? Not 0.5. 0.5 is down here. Does the function start down here? No, it starts at 1.5. Remember, the sine starts at 0. So if we all of a sudden start at 1.5, we've gone up 1.5. So our vertical shift would be plus 1.5. Okay. Now, we actually have to write the period properly before we can put it into a regular function. Okay? So, the period we need is between 0 and 2, right? But sine has a period between 0 and 360 degrees. Okay? We need to change this. So, here, I'll use E. We need to change this so that it goes between 0 and 2. So how would we do that? Well, how do you turn 360 into 2? Yeah. What are you going to divide by? Good. So if you divide everything by 180, you get 0, because 180 divided by 0. You still got t over 180 less than 2. Okay? So then that means our sine is now t over 180, and t is between 0 and... This doesn't work. I think I'm writing something backwards. Let me double check. Oh, yeah. Okay, so sine t to be between 0 and 2. So this is 180 times t. There we go. So now t is between 0 and 2. So how do I want to say this so that it'll make sense? Because, so what we're going to do is graph the function. So we need to write the function down. So we need to actually write it with all its shifts, remember? So like y equals 0.5 sine plus 1.5. So we need to write the proper thing on the inside with t between 0 and 2 to give us our full interval. So since we're using degrees and not radians, we're using 360 degrees. Not x plus, because if t is 2, then we only have 182 degrees, right? So we have to multiply between 0 and 2. Not plus or minus. Remember, we're only going between 0 and 2. See? We're only going between 0 and 2. Even 4. So that's not enough. Okay, so this is what we needed to get. This between 0 and 360 degrees, that's our regular. We only have between 0 and 2, so we have to make it so that this inside portion for t between 0 and 2 goes between 0 and 360. So it's 180 times 0 is 0, so that's our starting point. All the way up to 2, 180 times 2 is 360. Boom, we've got our full interval. So it's 180 t. Remember, this number right here, when we did our period, period is 2 pi divided by, you use degree, 360 degrees divided by b. I think that's the one you use. Your texty book. Where is your general function? I want to make sure you've got all the right variables written the same way. Your textbook is awfully bad at explaining things. Holy cow. I read it for a while and I was like, it didn't explain anything. It just gave questions. To be? Okay. Reality TV? Thanks for following though. Okay. Here, let me go back to this idea. Remember, if you have this function, so y equals a sine of bx plus c plus d? I think that's the general form that you would write. The period, different. Wish I could find it in your textbook. Somebody writes these functions like different letters, and it's the same. No, you don't have to. Well, function there. You write it like this. A times x minus b plus c. Okay. And then for the period, you write your doesn't tell you. I remember reading this, it's just like, do this instead of telling you. 360 divided by k. Okay. So, remember that the period in this function is 360 divided by k, right? That's what you have to do to get it. You change it to be like that. Since our period is between 0 and 2, our period is between 0 and 2, we need to find out what our k is. Okay, so 2 is equal to 360. Okay, so cleaner. K is equal to 360 divided by 2, so k is equal to 180. So when you write your formula, y equals sine of 180 times x. Just, you don't copy, bud. Just write your own notes for what you need. You know what I mean? This is mostly just scribbles. So this is your regular period. Yeah, do your assignment in your own way. Don't be copying down this. This is scribbles. Explanation. You still have to do this question because I didn't go through and talk about the rest of these. Like, what does it represent? You can write that down. What does it represent? What does it represent? You can write those down. Yeah, I highly doubt you're going to, eat garbage. Okay, so this last part, determine the equation. Well, we've got the period change is 180 times x. We've got the shift. We've got the amplitude. All we needed was that 180 times t. So there's our equation. Y equals 0.5 sine 180 times t, because t is our x-axis. And then we have a shift of 1.5. The last part is asking what's the domain in the range in terms of the situation. So that we can just get by looking at the graph. What is the domain of this function, this graph? Do you remember what domain is? That's a better question. I don't know what you mean by XER. So the domain is the values where the function exists for the x-axis. Okay. Since in this context of this question, we don't have negative numbers. Okay. There's no negative value, so there's no negative time. So the domain is only positive time. right? From 0 to, looks like it goes on forever. So from 0 to infinity. The domain. Does that make sense? Okay. The range is the y values where the function exists. Well, the function only exists in this little area of the y values. Okay? So what is the range for this function? Okay. It was a quick question, though. Could have answered it first. Feet. We don't do feet. It's meters. How you been, bud? Okay. Next. Okay, you go start your laundry. We'll be here. Yep. He's got it. It's just that I wanted to say it in simple terms. Yeah, for a lot of money, I would. For a lot of money, I would. I've, yeah, not a lot of pennies though. It would have to be a large amount of pennies. Not a lot, a large amount. You know, as a substantial weight. I've had a few students that keep messaging me on Instagram saying that they want to pay me to do their homework and stuff. And I'm like, sure, $10,000 a question. Because that's not how this works. Are you gonna go do your laundry real quick? Because the sooner you do your laundry, the sooner we get back to work. We do have 2 days though. So, Robbie, today is Sunday. Tomorrow is Monday, but tomorrow's a holiday, so the kids don't have school tomorrow. So we've got 2 days to finish his assignment here and study for his 2 tests. I know, right? Back in my day, we just did our homework first. So why do your parents want to go to the zoo? Well, back in my day, we walked 10 miles to school, uphill both ways. Anyways, can we move on? Yeah, okay. Go do your laundry. Okay. Well, then I'll go back to looking and working on this until he comes back. Probably, have you been following what I've been making lately? Yeah, yeah. Slowly. It's weird. There's peak times where I'll get like a ton of followers and ton of likes and comments and stuff. And then other times I'll do a bunch of posts and get like nothing. It's weird. Yeah, lots of people like to do that from time to time. Do it this way, do it this way. You know, it's funny because I started last year in summer and it was fine. Got quite a few people that always want to do summer courses. And I am definitely a fan of summer courses because they pump them out faster. Yes. No. No, I haven't. No offers from anybody. Funny enough, I'll get people that have like 30 followers. They'll message me and be like, hey, if you like my page, you should reference me. And I'm like, why would I want to do that? I need to grow. I understand the idea of like wanting other people to grow, but come on. Every once in a while, I get people that want me to like donate a bunch of my stuff to their website or something. F times G prime plus GF prime. I think a lot of the reason why I don't get any offers from any sponsors or anything of that sort is because it's math. I don't think people even realize that it exists. And there's meme pages with like hundreds of thousands of followers, and I'm like, why? All you do is steal memes. You don't even make them yourself. right? I don't understand. Uh, Okay. I want this. Stupid maths websites that everyone uses that take a big chunk of money from the education department for doing f of x is 3x find f of 2. So, yeah, I've been noticing quite a few people sending me these, like, they ask me questions, but they're all like online websites where you have to hand stuff in. Yeah, the homework website. And I don't know why they do that. I can understand it for some like calculus thing where they have hundreds and hundreds of students in like a first year course for homework, but like for like doing 30 students in a high school course, it doesn't make any sense. Or even I saw one that's a grade 8. They literally have questions. Is the it's something like 2x equals 2x plus 10. Is this solvable? And they'll have a question like this, and they'll have like 4 bullet points or something. Yes, no, and like x equals 5. Like honestly, you pay a lot of money to have a website to do this kind of work for students. They're so confused. They're so lost. I have grade 8s sending me messages about like these types of questions. And it's like, can't you just do the algebra? It's one step. It's weird. That's all I gotta say. What was I doing? Yeah, internet homeschooled North America. Honestly, that's a good market though for me because how many people have no idea what they're doing? Right? All I have to do is get them on here. Okay. However, I need to pause. Yeah, this is more than that. Yeah, it's true. Most of the courses are just here's an example. Go do it. No, this is yeah, you're right. This is more this is more explanation. Okay, I'm gonna be right back. $25? Thank you very much, Bet. I'm just gonna quickly go have dinner. And I'll be back to work on. Thank you very much for the 25 bits. I'll be back shortly. I'm just gonna quickly go run and eat. Okay. I have returned it. I have returning. Let's see. FTW, you here, bud? Hey, bud. Let's see, which question are we on now? 4. Oh, we were going to talk about the range, right? To make sure that you went through. What was the domain and range of this question? Well, bud, what's the domain and range? Okay, so let's go back over domain and range. Domain. Simple way to put it is just the values of x that the function exists. So if we have a function like this, and let's say that it only starts here. Let's call this 20. This is 0, and this is our x-axis. Okay? The domain is the values of x that exist. Well, the function has a value here, here, all the way along up until 20. Okay? Doesn't have any past. There's nothing over here in the negatives. There's nothing past 20. So the domain is between 0 and 20. Or, if you want to write it this way, 0 is less than or equal to x, which is less than or equal to 20. You see how that works? Okay. The range, so let's say this lowest point value is at -1, and this highest point value is at 5. The range is the values of y that the function exists. Okay? So for this one, the range, remember this is our y-axis, well, this graph only has values between -1 and 5. So the range would be between -1 and 5. Or if you write it differently, minus 1 is less than or equal to y than or equal to 5. See how that works? So, going back to our other question. What is our domain for this question? Remember, domain. One is right here, but this function extends way past 1. The domain, no. Where are you getting these values from? The graph. Look at the graph. Remember, it's an interval. But where does the function start? Obviously, it starts at 0 for time, right? Because we can't have a negative time in this type of question. We always start at time equals 0, not time equals negative 10. You know what I mean? So we have 0. This has an extension on the t-axis, so it actually doesn't even end at 4. It goes on forever. So the domain would be from 0 to infinity, assuming they did this forever. Another way you could say it is just that t is strictly greater than or equal to 0. Because our function starts at 0, goes on forever. I just said that it goes on forever. It doesn't end at 4. There's a little arrow at the bottom that says it goes on. It extends past 4. 4 is here, and it extends past. So 0 is the starting point, and it goes on forever after 4. So the domain would be from 0 to infinity, or another way to write it would be 0 strictly less than or equal to t. See what I mean? Now, what is the range of our function? Think about the range here. It's the y values that it exists. We only have this area that it exists. What is this range of values? No, the range is the y values. No, this value is 1, so it's not from 1.5 to 2. Remember, it's the y values. This whole y value area. Remember our example? Our example went from the bottom value to the top value. That was the range. So for us in this question, the range is from 1 to 2. So our distance, f of t, goes from 1 to 2. Which I would write for you as range is either from 1 to 2 inclusive, or written as 1 is less than or equal to f of t less than or equal to 2. You see how that works? You want to compare these two values. So if I give you another question on domain and range, would you be able to figure it out based on just what we talked about x values and y values? Okay. Then I'm going to just draw a quick graph, and I want you to tell me the domain and range, because it's the same all the way around. Okay? If I draw a graph like this, and to 1/2. Sure. No. Let's just extend it on forever. And this is from 1, and this is 2. Okay. This is our function. Doesn't look like much of anything. It's a made-up function. It's a piecewise function. Doesn't matter what it's drawn as. The concept still stays the same. What is the domain of this function? Nope. Okay, you want to start with the range? We'll start with the range. Don't give up. That's none of that is good. Don't say it's retarded. Just follow along. You'll be fine. Range. You want to start with range. Range is all the y values the function exists. Sure, from this point, it's only between -1 and 1/2. But afterwards, it goes all the way down forever. Which means the range from all the y values that the function exists has all the way down from -infinity all the way up to 1/2. See what I mean? Now, what is the domain of this function? So the range, the y values, and it's from minus infinity, open bracket, to 1/2. What is the domain of this function? No, not quite. It's missing a piece. So there's a gap in the domain. It doesn't exist between 1 and 2. So you just have a gap, right? Remember, it's always the same thing. The domain is the values that the function exists for the x. It exists between -1, or from 0 and 1, because this is 0. So it exists between 0 and 1. But it also exists from 2 to infinity. Because here it exists and goes forward, and here it exists up to here. The process stays the same all the time. Okay? So let's take a look at the next thing that you have on your question. 4. Seems pretty simple. Do you know how to do 4? No, just break it down. 4a, y equals 3 sine x plus 2. It has 3 complete cycles. Okay? Determine the period, amplitude, equation of the axis, domain, and range, and without graphing. Pretty simple and straightforward. So let's do a quick example of it. The first one is y equals 3 sine x plus 2. 4a. Okay? Three cycles. We need the period, amplitude, equation of the axis, domain, and range. Okay. Amplitude is 3. Good. And it's shifted up 2. Good. Okay. 3 cycles. Now, this sine x, there's nothing in there. So what's the period? No. What's the period of the regular sine function? The regular period. 360. Good. 360 is the regular period. 3 cycles means it goes 3 periods, right? So, just as like a quick line drawn, here's 360. That would be like 1 full cycle. Okay? But we need 3 cycles. So that's 2. That's 3. This here would be what? 720? What's another 360 on 720? This would be 1080. Right? You following me there? Let's finish this one and we can work tomorrow. You should be able to do the rest of these, at least half of it, on your own. If you can't do the domain or range, or if you can't do some of it, that's fine. But for the most of them, you can just still start filling out a bunch of stuff, like the amplitude and all that stuff. But anyways, this is 3 cycles. Which means it's 3 times the period. Okay. For like, no, 720 is times 2. Yeah, 1080. 3 times the period is what we have as our kind of domain. Because our function starts at 0. It says x equals 0 is the start. Okay? We want to find the final endpoint for our domain. So that's going to be right here, the end of 3 cycles. So 1080 is 3 cycles. Does that make sense? Okay. So now we have to just find out our range, because our domain is right here. We need the equation of the axis as well. Well, the equation of the axis is pretty simple. It's just going to be our shift. For example, sine x starts at 0, so here's a regular sine. Equation of the axis is y equals 0, because this center line is the axis. If we shift it up, just say 1, so that it goes from here to here. Oops, bad drawing. Then here's our center line that's new. This is sine x plus 1. Right? So our shift is our equation of the axis. So for us, our equation of the axis is our shift up, which is 2. So equation is y equals 2. Make sense? It's awesome. What else did we need? Equation of the axis, domain and range. We have the period, we have the amplitude, equation of the axis. Okay, domain. Well, we found out that it started at 0 and ended at 1080. So that's our domain. Started at 0, which is less than or equal to x, which is less than or equal to 1080. Okay. Range. Well, the range is a mixture of the amplitude and the shift. So the range, we have 3 times sine x. So if we don't include the shift, it would go from 3 to minus 3, right? Hey, Wills, how's it going? If we went and changed this to include the shift, remember it's plus 2, so this would shift up. So this would be now a 5 and a minus 1. So this would be our range. Namaste. Hey guys, how's it going? I don't know what that is, but okay. So FTW, do you see what the range would be for this function then? So what is the range for this function based on what we just went through? Okay. Going back. So the range of the regular sine function, right, is from 1 to minus 1, right? Okay. The amplitude multiplies that range. So times 3 gives us 3 to minus 3 because of the amplitude. Okay. But we still have to do that shift because it's 3 sine x plus 2. The shift is add 2. So that means the minus 3 plus 2 goes to minus 1, and 3 plus 2 is 5. You see how that changes? How that adds up? Going from the regular times the amplitude plus the shift. This is the range. So the range, no, I didn't get the 3's from the 3 cycles. Range is not the cycles. I got the 3 from this right here, the amplitude. We used the 3 cycles to find the domain. It was just a coincidence that the amplitude was 3 and it using 3 cycles. So I'm going to ask you again, what is the domain of our function? I want you to look at it. Remember, we had 360 degrees is the regular, and we want 3 cycles. So the domain starting from 0 to what? That's the original. That's 1 cycle, but we need 3 cycles. Good. What is the range of our function? You should have this. You were supposed to be working on your own notes at the same time. The range of the function. You can figure it out right from here. Remember, y equals 3 sine x plus 2. Range of the original function goes from what to what? What's the range of sine? No, just the regular sine. This one right here. What is the range of sine? You could even look on your regular reference sheet, wherever I put it. No. The range of a regular sine function. The regular sine function. Just the regular one. What is the range on a regular sine function? No shifts, nothing. You can even look on the base graphs that I've sent you before. I can even send you again. Look at the sine function on the page I just sent you. And bring it up here for us. Page 5. Nope, that's 4. Page 5. Sine. -1 to 1 is the range. -1 to 1. Okay. -1 to 1. Then, because of this, it goes to 3 and 3. But then you still need to add 2 because you're not done yet. You'll need to add the 2. So what's the range of our function? -1 to 5. There you go. Do you see how we got each of those values? Okay. Glorious. B is next. Or are you done for now? Because it'd be what? 20 after 9. Yeah, you'd be done for now. When you're in high school, it's not a good time. When you're in university, I mean, it's a normal time. Go play a game or something. Go relax. Okay. I think you told me before it was like 51 or 2 or something. Yeah, 51.1. Which your math mark should be is like 75 or 80. You gotta the anxiety part. That's a problem. You gotta stop having anxiety. If she drops it at the end, that would be the greatest. Yeah, I see what you mean. There's a huge difference in the numbers. Yeah, it doesn't sound like your environment would be that great. You need the basic understanding of math to do good, and it's about the logic, not so much about just like how do you solve a problem. It's the logic behind it that you need to get good at. Even more so, business, you need to know logic. It's all about the logic, not necessarily about how do you solve a differential equation that's nonlinear and blah 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 blah. No, the logic is here already. You just need the basic foundations. Like how I'm going through the domain and range of this function is all based on just like the logic. You know what the base is, so how do you change it to go to what we need, right? It's not like all of this isn't theoretical. This is real numbers. And they're not even really fake. It's just kind of like just basics of understanding in the simplest form. So when you get amplitude all the time, think about radio waves, engineering, cyclical things. Amplitude would even be used in market cycles. So, for example, in business, you'll have a cycle every year if you have a cyclical market. So, like flowers. In North America, we go through summer, winter, we got fall and spring, we have all these different seasons, right? There's all these cycles. Yeah. Some have up, some have down. What is the amplitude between your cycle? And is it changing? That's how you measure your growth, right? So, like, this is a simple form. Want to know trends, all that stuff. Okay. Well, it's only 7:30 here, so got a few people asking for other things. I might be turning off though. Yeah, no problem, bud. See you later, bud. So, the question is about this Kashmir problems with inverse trig function. I go into a lot of things that I don't really have a lot of notes on. I'd have to just write some notes and then go ahead. Question. So, I'll have to do that off stream. I'll be going elsewhere to write down some notes and stuff. So I'll tell you what, this might be good for now. And we'll pick it up another time. I'm thoroughly surprised by those that donated, though. Pretty awesome. And who follows. So I'll catch you guys later.